So low-key, this is the last major topic that you're going to need to know before the Regents and before we start like test prep and going over stuff that we've done before to make sure that you understand it better. So this is statistics part 2, okay? So we're going to find a couple of things. So first thing we're going to do is we're going to start out with simplifying. So if it says 8 plus or minus the square root of 25, I just want to bring this down here. We have two different scenarios. We have 8 plus the square root of 25, and we have 8 minus the square root of 25, okay? So what does this mean? Like, how can we simplify this? We know that the square root of 25 is the same thing as 5. So this, on the left-hand side, we have 8 plus 5. So 8 plus 5 is 13. Good. So this is equal to 13. So one answer is going to be 13. And then this one right here is the same thing as 8 minus the square root of 25, which is 5. And 8 minus 5 is equal to 3. Okay. So 13 and 3 are our two values if you have something like this. All right. So you'll see why I had that for the do now in a bit, but I want to talk a lot about this right here, okay? So this is called the bell curve. You can pretty much put anything on the bell curve, like ages, people's ages, weight of people, IQ scores, SAT scores, anything, okay? A lot of things fall into this normal distribution curve. It's also called a bell curve. And so things that you need to know about this curve is if you take right down the middle, right? If you take this right here and you cut it right down the middle, for a normal curve, this is going to be the same thing as the mean, and it's symmetric, right? So like if you take, this is 50% of the population, so 50%. And then this side right here is 50% and this side is 50%, right? So it takes the full 100% and cuts it into two. So this side right here is below the mean, and this side right here is above the mean, okay? So that's symmetric about the mean, okay? So other things you need to know, the mean, the mode, and the median with a normal distribution curve are all the same thing. So this is the same thing as mode, and this is also the same thing as median, okay? So just to refresh your memory about what this means, right? The mode is the number that appears the most. You should write that down if you didn't know this. Median is the number that's in the middle. So in a normal distribution curve, the mean, the median, and the mode are all the same, okay? So that's basic property number 2. The mean divides the data in half, right? We kind of talked about that already. Defined by mean and standard deviation. So there's this, we know what mean means, right? Take all the numbers, add them up, and divide by the number of numbers. Standard deviation, I don't know if you've heard of this word before, but I wanted to draw a picture for you, okay? So these two graphs right here, I'm taking a little bit of a commercial break. So this graph in blue and this graph in green, what you should notice about them is both of them have the same exact mean, okay? The mean in this case is 5, if I drew this a little bit better, okay? So the mean is 5 for both graphs, right? Because that's the peak of both. But this green graph right here is more wide than the blue graph, right? The blue graph looks something like this. But so the green graph, this one right here, is more wide. That means that it has a higher standard deviation. That just means how wide or dispersed the graph is. So that's what standard deviation is. Okay. And the symbol for standard deviation is going to be, it's like a little person with a hat. It's like a O with a line on the top. Okay, so that's a symbol for standard deviation. Sometimes you'll see it like that with an X on the bottom, but that just means the same thing. So this is population standard deviation, SD. Okay. So it says the mean of both graphs are we kind of talked about that already. They are the same, but the blank is different, right? And we just introduced a new word or two new words here, but the standard, so please fill this out on your paper. The standard deviation is different. So variance is 2 times the standard deviation. So that's another thing to know that once in a while comes up, and we'll talk a little bit more about this in a bit. All right, so defined by mean and standard deviation. Again, standard deviation is how wide or dispersed the graph is, okay? The curve is unimodal, which means that there's one peak, right? There's no two humps or two peaks. There's only one. The curve approaches but never touches the x-axis, right? So you see this right here, kind of gets really close to the x-axis but never crosses it or never touches it. And the total area under the curve is 1, okay? So if we take all of these probabilities right here, and the probability of getting into any of these right here, and we add them all up, that's going to be 1, which is the same thing as 100%. So 1. All right. So this will become a lot more clear as we go through a couple of questions. But I do want to go through empirical rules, so you don't need to know what this is called. You do need to know, though, that if you have a normal curve, right, this right here again is the mean. So the symbol for mean can be like an X with the bar. It's also can be like a U. I said this in the last video in part 1 statistics. So mu and X bar, they both mean mean, okay? The mean. We talked about what this little symbol right here means, right? That's standard deviation. So this right here is your mean plus the standard deviation, right? Because we're moving to the right. And this side right here is going to be the mean minus 1 standard deviation, minus 2 standard deviations, minus 3, okay? So whenever you have a problem and they give you something like a question of this, which we'll go through a few of them, to find out, like, for example, if they tell you that the mean, which is the same thing as this right here, is 50, okay? So I'm going to go right here. Here's our mean, and I'm going to put 50. And then I tell you that the standard deviation is 3, okay? Let me just kind of go through this with you. So this right here, this one section is going to be 50, and we're going to add the one standard deviation to it. So 50 plus 3 is equal to 53, okay? This one over here is I'm taking this number, the 53, and I'm adding another 3. That's the same thing as taking the 50, which is this right here, and doing 2 times the standard deviation, which is 3. So that's going to be 56, right? 53 plus 3 is 56. And this last little section right here is going to be 50 plus, this is 3 standard deviations away, right? 1 section, 2 section, 3 sections. So it's going to be 3 times the standard deviation, which is the same thing as adding another 3 to this. So that's going to be 59, okay? If I go this way, I'm not adding now, right? I'm subtracting. So 50 minus 3 is going to give us 47. Minus 3 again is going to give us 44. Minus 3 again is going to give us 41, okay? So what you do need to know is within the normal curve, right? Within 1 standard deviation, right? Right here, within 1 standard deviation, that means +1 and -1, 68% of data falls there, right? So if there's a survey that you're doing and it falls within the normal curve or it goes into a normal curve when you graph it, 68% of the data falls between +1, -1 standard deviations, okay? So that number is important. The next number that you do need to know is between 2 standard deviations, right? So if I take all the percentages and I add this up right here, that's going to equal 95%. So 95% of the data fall within 2 standard deviations, between -2 standard deviation and +2 standard deviation. We're going to talk a little bit more about this. And then the last one is 3 standard deviations, which is, right, most of the population is going to fall 99.7%. So 68, 95, 99.7, okay? The one that's asked most common is this 95%, and we'll do a couple of problems with that. And the last one is just margin of error. Once in a while they've asked this question. I just want you to know it. We are going to go through a model problem explaining how to do this, okay? All right, so model problem number 1. So given the normal distribution of values for which the mean is 70, so that's important, and the standard deviation is 4.5, that's also important. Find the probability that a value is between 65 and 80 inclusive, okay? So what that means is we have our curve, right? They're telling us that the mean is 70. They're telling us that the standard deviation is 4.5, okay? So we want to find that the probability that a value is between 65 and 80. So if we try to do it the way that we were doing it before, 70 plus 4.5 is 74.5, right? And if I take that 74.5 and I add another 4.5 to it, 74.5 plus another 4.5, we're going to get 79. So that's really close, right? We don't want 79 though, we want 80. So we have to use our calculator. And let me just show you the easiest way to do this on the calculator is you see above this vars right here in blue is distir, that stands for distribution. So we're going to go ahead and hit second vars, which is distribution, and we're always going to use number 2, normal CDF. We will never use number 1, normal PDF. So let's hit number 2, and then it asks us for some information. So it says, what is the lower? So it's the probability that a value is between 65 and 80. So let's take our calculator. So our lower is 65, they give it to us, and our upper is 80. So let's put 80 there. And then this symbol right here stands for our mean. So we know that our mean is 70, so we could put that in. And then the last thing that they need from us is 4.5, which is the standard deviation. So let's put that in. You hit paste, hit enter again, and it gives you the percent, the probability. So this is going to be 0.85. If we round this to the nearest tenths, hundredths, thousandths, 0.854. So 0.854, which if I wanted to change it to a percent, is 85.4%, okay? Because I'm moving the decimal 2 places to the right to make it a percent. All right, so that's the first one done. Part B, the probability that a value is greater than or equal to 75, okay? Greater than or equal to 75. So visually, just so you know, that is from here up, right? So we know that the total percent is 100%. So I just want to show you this right here. And we know that this number right here keeps on going, right? Like if I want to extend it, it keeps on going. So it says a probability that a value is greater than or equal to. So whenever I'm looking for probability, I'm going to do second distribution, right? Second vars, option number 2. So now, right, let's go ahead and clear this. So now it's saying greater than or equal to 75. That means that 75 is our lowest. So I'm going to go ahead and put the 75 here. And then for our upper, right, we don't know what the max number is, the number that's all the way to the right. So what I do is I always just put like a really big number, a whole bunch of 9s, 9, 9, 9, 9, 9, 9, 9, 9, 9, 9, right? Our mean is still the same. It's still 70. And our standard deviation is still 4.5. Hit enter, and it gives me 0.133. So 0.133, which is the same thing as 13.3%. All right. Next, the probability that a value is less than 62. Okay, so 62 is going to be somewhere over here. Let me just go ahead and change the color to this weird orange. So 62 is going to be somewhere over here, and I'm looking for less than that. Okay, so now I'm going to do the same thing, second vars, option number 2, right? That's what I always pick. Now for my lower, right? I know like over here, all the way right here, I don't know what the smallest number is. So what I'm going to do is I'm going to put the smallest number that I know, which is negative 999999999. Okay, you could put 0 there if you want. And then for the upper, the highest number that we're going to have here is, it says 62. So our upper is going to be, that's the highest number that it can get. So I'm going to put 62 here. And again, our mean, right, because it's still the same problem, is still 70. Our standard deviation is still 4.5. Enter, enter. And it gives me 0.038. 0.038. So 0.038, which if I change that to a percent, that's 3.8%. Okay. And again, all these values are rounded to the nearest tenth. And then our last question says how many, right? It doesn't say the probability, it says how many. So out of 50 have a value less than 62. So I know this is our percent. So what I'm going to do is I'm going to take that number and I'm going to multiply it. How many out of, the word of means to multiply. Let's go ahead and change this. So I'm going to multiply by 50, which is the total. So now I'm going to go over here and multiply it by 50. So whenever it asks for me for how many, I take the percent multiplied by the total. And it says that's about 1.89. So about how many 1.89 have a value less than 62. Okay, that's model problem 1. Model problem 2. Mary bought a pack of candy. The manufacturer claims that 30% of candies manufactured are red. So these statistics problems, sometimes they're really long for no reason. Like if you take a look at some of the questions that are there, like look at this question. It like literally lasts the whole page. But it's not that complicated because a lot of times you're just skimming for certain things. In this case right here, we are skimming for this right here, our mean and our standard deviation. And how do I know I'm skimming for that? Because it says the middle 95%. So you should definitely write this down. Whenever it says the middle 95%, the formula is always going to be take the mean plus or minus 2 times the standard deviation. Please write that down. To find 95% confidence interval, okay? Confidence interval, confidence interval. You do mean plus or minus 2 times the standard deviation. All right, so what is the mean? The mean is 0.301. The standard deviation is 0.058. You can put the 0 there if you want. So now you just take your calculator, right? I'm going to clear what's there just because it's a different problem. I'm going to move my calculator over. So I'm going to use our formula, right, to find the confidence interval of the 95%. So take the mean, 0.301, right? So this is 0.301, and I'm going to do plus or minus 2 times the standard deviation, which is 0.058. And again, I have two parts, right? I have 0.301 plus 2 times the standard deviation, 0.058. So that's the first one that I'll put into the calculator, plus 2 times the standard deviation, which again is 0.058. Close those parentheses, hit enter. So I have 0.417. Okay, so 0.417 is when I add them, that's what I get, 0.417. And then when I subtract them, now watch how easy this is, right? I'm going to work smart, not hard. I'm just going to go up, right? Hit the up arrow, grab this by hitting enter. And I want to change that plus sign to a minus sign because I want to go through this path right here, which is 3 minus 2 times the standard deviation. Hit enter and I get 0.185. So the other value is going to be 0.185. 0.185 is smaller. So it says, based on the simulation, determine the middle 95% of plausible values that the proportion of red candies in a pack is within. So it's from 0.185 to 0.417 is my answer to this question. Okay. So again, we're good. This formula is very important. As soon as you see middle 95%, mean plus or minus 2 times standard deviation is the formula that should come to mind. And then it just is skim and find out where the mean and standard deviation are, and then plug it into the formula. Okay, so that's model problem 2. One more question and then we're done. Sorry that this video is a little bit longer, but they do ask a lot of questions about this. So Emily and Terrence drew samples of chips from a mystery bag of a total of 50 chips. So the total is 50. That is going to be our N. So our N is equal to 50 is important for us to know. Emily drew 42 red chips. Okay, so Emily drew 42 red chips and Terrence drew 40 red chips. So it says find the margins of error for each student. Okay. So to find Emily's, what we're going to do for margin of errors, we're going to plug it into this formula right here. Okay. So before we could do that, we know what N is. N is 50. So we're going to put the 50 here. Can't forget that there's a 2 in front. And then we have to find out what numbers go right here on the top. So how do we find our P? What would find P by doing the probability of Emily drawing a red chip, which is 42, right? There's 42 red chips that she drew out of 50 chips. So 42 divided by 50. So let me take my calculator, do 42 divided by 50, and that's 0.84. Okay, so my P is going to be 0.84. My 1 minus P, right? I go to my calculator and do 1 minus P, which is 0.84. I hit my up arrow. I go grab that just because I'm being a little lazy, and I get 0.16. So my 1 minus P is 0.16. And that should both add up to 1. 84% plus 0.16 or 16%. So I'm going to plug that in here, right? So my P is 0.84. And I'm going to multiply that by 1 minus P, which is 0.16. And now I plug all of this into the calculator, and that gives me the margin of error for Emily. All right, so I know I have to put a 2 here, and then I have to put a square root. I have to get this fraction here, so I hit alpha y equals, hit enter. So I have on the top 0.84 times 0.16, and on the bottom I have 50. All right, so margin of error for Emily. Let's see if we can change this to a fraction. Probably not, but I'm going to try. Okay, it's the same thing. So 0.104. Okay, so the margin of error for Emily is going to be 0.104. Good. Now I'm going to find the margin of error for Terrence by doing the same thing. Okay, so now I have to get my P. Let me go ahead and change my color. So my P is equal to, right? How did I get our P? By taking the number of chips, red chips that Terrence drew, which is 40, out of the total, which is 50. So 40 divided by 50, I could do that easily on the calculator. 40 divided by 50 is equal to 0.8. So my P is 0.8. My 1 minus P is going to be, right, take our calculator, do 1 minus this number that I have here. I know that's going to be 0.2, right? This is 80%, the rest is 20%, so that's 0.2 or 0.20, whatever you want to put. So now I have these two values, and the last one that I need is my N. My N is 50, so I'm going to go ahead and plug it into my formula. So 2 radical, right? On the top, I'm going to have 0.8 times 0.2, and on the bottom, I'm going to have 50. So I'm going to go here. Instead of typing everything over again, let me see if I could just use this right here, right? Work smart, not hard. And instead of 0.84, I just want to do 0.8. And instead of 0.16, I just want to do 2 and delete this right here, the 6, okay? So I'm going to hit enter, and it gives me 0.113. 0.113 is the probability for Terrence. So 0.113, all right? So what I want you to do is do the check for understanding, and then try some problems that are here for level 1. If you want to work a little bit, go through the other problems. They do get a little bit more crazier, but as you can see, right, as soon as I see middle 95%, I have mean plus or minus 2 times standard deviation that comes flying to mind, and I'm going to scan my problem for my mean, boop, and standard deviation. We can ignore all of this, okay? You'll see that happening quite a lot in statistics problems. All right, sorry that this video is a little bit longer, but it's important. Okay, good job.